Hello everyone. Today we will be working on the Unit 5 review. I want to remind you that, if you're watching this video, you're either watching it right before the test or you've already worked on the review packet. So you probably already know how important it is to work on these review packets. I will tell you that this particular review, I call it a packet, but it's really only 2 pages. This particular review is exactly identical to the test. So if you are able to do this whole review, you should be very confident in your capability for the test coming up. So again, usually in these review videos, I just kind of glance through a couple of the problems. I will not do all of them because again, the answer key is posted on Canvas, so you can check that out at any time and kind of look at all of the answers. I'll just kind of pick out maybe 2 in this top section. So in this top section, we are looking at this vertex form, which is given to you over here on the side. Sorry about that. Give me a second. There we go. Which is given to you over on the side. That formula or that standard form will be given to you on the test. It's not necessarily something you should memorize, but it is something that you should become fairly familiar with. Like if you're looking at this first example, it looks identical to this. What we know about vertex form is that the h and the k are going to be the values of your vertex. So when I look at this first one and I say, what is my h value? Please remember that right here, it is a minus sign. So if you are given a plus sign, remember you are thinking about what is the opposite of what's inside. So as far as my vertex goes, that will be a -4. And then the k value comes from what's on the outside, which in this case is a -3. If I look at another example, again, just kind of identifying the vertex real quick, please remember that this one has a minus on the inside. So that means when it comes to my vertex, I'm going to actually be +2, +2, and then the y value will be -1. Once you find that vertex, you can go ahead and graph that. So if I go back up to the first one, we're at -4, -3. So go to -4 down to -3. There's my vertex. It doesn't say anything about labeling, so don't really worry about that. You can be consciously thinking about whether this is, or where is the axis of symmetry. So in this case, I'm just going to kind of draw it in because we will use it later. I'm going to go ahead and put in that axis of symmetry. As far as kind of finishing out the graph, a lot of people kind of get stuck at this point, and you could do the X and Y intercepts. I think the easiest way would maybe be go straight to a table, because in a table you can pick any value that you want and kind of go from there. So maybe I'll pick -2 and I don't know, 0. Let's just try 0, see what happens. You can pick any value, it's just make sure you're staying consistent to one side. So if you pick the right side, pick any x values on the right. If you want to pick to the left side, pick any values to the left, but just stay consistent with those two. So I'm going to take this value up here and plug it in and see what I get. So for -2, I'm going to get plus, that becomes +2. I'm going to square it, that gives me 4. 4 times 1/4 should just give me 1. And now I'm at 1 minus -3 will give me -2. Again, you can type that in your calculator. I'm kind of just doing it in my head. Over here, if I do 0, that's going to be 0 plus 4 gives me 4. If I square that, that's going to give me 16. 16 times 1/4, again, you could do that on your calculator. I'm going to tell you right now, gives you 4. And then -3 gives you 1. So now I have those 2 points, and I can go ahead and graph those. So I'm at -2, -2. I'm at 0, 1. And I will tell you, if you pick some other numbers, I saw a lot of people that picked -3 as one of their numbers. If you pick -3, I believe it comes out to be -2.75. That's okay. Sometimes you will get decimals like this. I just happened to pick 2 ones that worked out to be nice numbers. But if you get a decimal, just kind of eyeball where, -2.7 would be. For example, -2.7 would be right about here, which does kind of match my curve. If I went ahead and did the curve, it would kind of fit right in that area. Remember that the axis of symmetry is there so that I can mirror it. So on this level, I'm 2 away, so I need to be 2 away. On this level, I'm 1, 2, 3, 4 away, 1, 2, 3, 4 away, and that kind of gives you the mirrored curve. So you only really have to do 2 points, and then the other side will kind of work itself out. Example 3, I gave you guys the vertex at 2, -1. Again, just kind of take it away with the table. Pick any values. I would probably maybe pick 3 and 4. Some people pick 1 and 0. That's fine. Just be careful plugging it in, getting those values over here, and going ahead. I will say that a reminder that if there's a negative out in front, odds are it's probably going to be going down in some shape or form, because that negative tells you that it's a frowny face and it would be going down. This one, I can look at this and know that it's probably going to be going up because 3 is positive. So that's about a review of the top section. The next section in this particular one, reminder, basically the big thing here is to remember to simplify this as best as possible. So for the first one, I would say FOIL this. So you're going to get that 2x squared minus 4x plus 4x and then minus 8. The two middle terms end up canceling out, and your final simplified answer would be this 2x minus 8. I want to remind you here that when it comes to classifying whether it's linear or quadratic, it doesn't matter how many terms it is. All that matters is, does it have an x squared? This one does, so it would have a quadratic. Then you can figure out the quadratic term, linear term, and constant term. The quadratic term would be that 2x squared, and then your constant term is negative 8. Reminder that most of the time, if you don't have a term, like I don't have a linear term here, I'm just going to call it 0. Unless, for example, number 7, this is going to work out to be linear instead of quadratic, in which case when you're listing the 3 terms, your quadratic term is actually going to be NA, because if you had a quadratic, then we would have called it quadratic. But because we don't have one, it's linear and you just count that out. All other circumstances, you should be saying 0, but under this one single circumstance, you get to say NA, but all other answers should be 0. When you come onto the back side, these particular examples, let me pick red. I would highly recommend, we need a y, we need an x and an h and a k. So what we are solving for is going to be this a value. So when I look at this, the vertex is always going to be h comma k. So you can kind of quickly look at both examples. Even this middle one that's unlabeled, just kind of label it. That's -2 comma -1. Pick another point, let's say this point up here, that's going to be 0, 3. You'll really only need 2 points, one's the vertex, one's the other one. This is going to be your h and your k. When they give you kind of options, it doesn't matter, pick one, call it x and y. We'll call this x and y. There's 4 here, you can kind of pick which one looks easiest. I'm going to go with this one, x, y. And then basically all you're doing is taking this formula up here and plugging in what you got. So over here I have y is 1, equals, a is what we're solving for. My x was 0 minus h. H was a -1, so keep in mind this is going to be a double negative. So I'm just going to go ahead and write that as a +1 and then square it. Please don't forget the square. That's probably the biggest mistake people have, is this square. And then plus k, so that's +3. If I go ahead and solve this, that's going to become 1 squared, which is still just 1. So I have 1 times a plus 3. Send the 3 over to the other side. That gives you -2 equals a. And then as far as finishing out your answer goes, they do ask you to write the equation. So we're going to have y equals, my a is -2. And then you have x minus h, which makes that +1. And then don't forget the square. That's probably the biggest thing here. And then +3, that's going to be my final answer. So that's pretty much what you're going to do for these 3, is you have your h, your k, your x, and your y. Just plug it into this equation up top. Solve for a. Once you get a, please don't forget to plug it back into your equation. And you should be good then. And I do expect to see you on the test, if you're doing a lot of this in your head, which I know some of you guys do, at least tell me what a equals and then have your equation down below. You need to have at least those 2 things. If you just give me the equation, I don't really know that you actually solved for a, especially if you get 1. For example, this one, you get 1, and then you're going to have all this information here. If you don't write 1 in there, I don't know what a equals. So at least define that a equals 1, and then go ahead and do your equation. And then the very last one is the one that kind of has a little bit of everything. You have your vertex, your axis of symmetry, your y-intercept, your x-intercepts, and then min-max. We've reviewed this a couple of times in class at this point, so I won't spend too much time on this, but again, this is your review video, so kind of giving you as much as you might need. I usually write the vertex as saying V and then having my point. So remember that vertex in standard form, if it was in vertex form, great, you could instantly tell like we did on the front. But when you're looking at one like this, you need to go over to this formula, which will be up on the wall. Think to yourself, what is your A? Please remember that this is your C value because there is no X. So in this case, my B is going to be 0. And then I come into my formula and I'm going to have 0 over -6, which is still 0. So that goes into my form or my vertex. A reminder that your axis of symmetry is always just going to be an x equals whatever you got. So that's 0. Then at this point, I can go ahead and plug it back in to solve for y. I'm going to get y equals 0 plus 6. Therefore, y equals 6. And plug that in. That then takes us to our min-max value. So I pause for a second. Reminder that for minimum maximum, you are saying what is your A value. In this case, my A value is -3, which means it's negative. It's a frowny face. So in this case, I will have a maximum. And then reminder that the value is going to be whatever your Y is, which is 6. So your 0 became there and your 6 came down here. Then let me clean this up a little bit so we have some space to work. Next up, we have to solve for the y and x intercept. If I go ahead and say y intercept and x intercept, a reminder, I always find it helpful to actually go through and write these in. That way I kind of know what I'm actually solving for with the zeros. So the y-intercept is never too bad. Basically, it's saying that your x value is 0. So I'm going to come up here and I'm going to plug in 0. You're going to have y equals -3 times 0 squared plus 6. That just gives you 0 plus 6, giving you 6. And my y-intercept is 0, 6, which we should have been able to already tell from the vertex is that the x equals 6. Then you get into the fun stuff. You're solving for the x-intercept. So this time y is going to be 0. And there's been a couple of problems we've seen like this where they only have the x squared. Hopefully we've reviewed enough times that you're starting to catch on. Try to get that x by itself. Divide by -3 is going to give me 2 equals x squared, and then I square root this. You will get a plus or minus the square root of 2 equals x squared. And then you can plug that in. So I'm going to have square root of 2 as one of my answers, and then the other one's going to be negative square root of 2 as my second answer. When it comes to graphing these, the square root of 2 might not be the most helpful. So what I would recommend is going with what you do know, that's 0, 6. That's about it. Again, the x-intercept's not too helpful. They're going to be about 1 point something. I'm trying to keep this video under 15 minutes. So at this point, I would say go with the table. Pick some values. I'd maybe go with easy ones like 1 and 2. Plug them in. That's going to give me 1 squared, -3, plus 6 gives me +3. And you can check my math again, just kind of doing it in my head. 2, that's going to give me 4, -12 plus 6 gives me -6. If I graph those, I'm at 1, 3 and 2, -6. And then I mirror that on the other side. And you'll kind of see your graph taking shape there. And you'll notice that, it is kind of crossing the x-axis around these intercepts, but not a big deal that I chose not to use those. You don't have to use them if you find that they're not helpful, but if they ask you to calculate them, like this one up here asks you to calculate them, then you need to at least tell me what they are. And then as far as graphing goes, you can do it in whatever means that you want. When it comes to the second example, as far as finding the x-intercepts, I will tell you that your best bet here, when you set equal to 0, is going to be to factor this. So what things multiply to 5 but add to -6? In this case, it's going to be -5, -1. And then you'll quickly see that your x values equal 5 and +1. And therefore, your intercepts are 5, 0, and 1, 0. So hopefully that kind of helps you get started with the next one. But that brings us to the end of this review video. Good luck on your test.